This lecture will talk about protocol stack, the internet's standard protocol stack, which involves TCP/IP. And I'll talk a little bit, give a little bit of example about an application layer protocol, what that would look like. We're not going, again, not into too much detail, but you should know what this protocol stack looks like, because anytime you want to use the internet, so if you want to write code that accesses the internet, you're going to be using this stack, this protocol stack. And so you'll want to know something about how it works. So typically, when you're using the internet, this is sort of a standard protocol stack that you see right here. This is not the same as the OSI protocol stack. The OSI protocol stack has 7 layers and is more complicated. This is simplified. This has 4 layers in it. Top layer is the application layer. Below that is the transport layer, where you see TCP/UDP, that's transport layer. Then below that you see IP, which is, that's called the network layer, and that's the internet protocol that's there. And then below that is what's called the data link layer. Actually, there's really 2 layers merged there, data link and physical. So the bottom layer is the physical, the very bottom that you don't see there, that's merged in, is the physical, where it actually wires it, drives it onto the wires, drives the signal onto the wires or onto the radio. And actually, if we look at these layers, so there's code associated with each layer, right? They're typically library functions. So in practice, in this specialization, when you write network code, and you will later, when you work on network code, we'll be talking about, you'll be calling application layer library functions. Only top layer, right? You don't have to worry about the lower layers at all, almost at all, right? Just the top layer is what you're really going to be dealing with. But this whole stack has already been implemented and it will be given to you. So you'll download a free stack that looks like this, but the functions that you'll be calling will be all top layer, application layer. But just say a little bit about some of these layers. There's so there's IP, we already talked about that, TCP, UDP, and the data links to physical. Application layer, these are the protocols that directly interact with the applications. So whatever kind of application it is you're writing, if it's a networked application, it will have some kind of a network protocol, an application layer protocol that it works with. So for instance, naming some application protocols, SMTP, Simple Mail Transfer Protocol. That is a protocol used by mail clients, right? If you got an email client, it might be using SMTP to communicate with the mail server. HTTP, Hypertext Transfer Protocol. Now, you've heard of that, HTTP : you've seen this in your URLs, right, in your addresses on the web, HTTP : / whatever. So anything that's HTTP, that's web interaction, which is most likely which is most commonly used for, actually in this class, that's what we'll be using later on. And then LPD is another one, line printer daemon. Printers talk to each other using that protocol. But there are a lot of these protocols. File transfer protocol is a bunch of them. If you want to transfer files, maybe you'll use file transfer protocol. Hopefully you use SFTP, secure file transfer protocol, because it's better than FTP. But the idea is every application, network application, has its own protocol at the application layer that it uses. So to give you an example, what one of these protocols looks like, let's look a little bit at HTTP. This is HTTP. This is like a typical request on the web, right? A little hard to see, but if you look at actually the one we're looking at right here, this is the response message. So it has several lines. Actually, that code right there has 6 lines. The top 3 lines, the ones in green, those are the header. And the bottom lines in white, those are the body, or the data, right, or the payload, whatever term you want to use. So the header are going to be basically those top 3 lines. Now, the header information, it gives information about the message, but it's not the actual content. So for instance, if we look at the first line, it gives you the protocol version, also the message type. 200 OK is, if you look at HTTP protocol, which you can Google it and get a very large protocol document, 200 OK has a particular meaning. Every response message is going to have a particular code. 200 OK is sort of your standard response, right? So then the next line there has a date, the date it was transmitted, and so on. The next line has a content length, so that's how big the data is. That's inaccurate, but that's an example. It'll have the content length, and there are a lot of different pieces of header information you can stick in the header. Now then the body, the data that you see there, that's the actual body, the content of the message. Now in this example, which is very common, if this is if you're asking for a web page, what happens is your machine, your IoT device, let's say, sends a request out to a web server, and the server sends back the content of the web page, right? And so that your IoT device can render the page and draw it for you on the screen. And so that, what you see there is HTML code, which is the content of a web page. So, this is summarized, but you can see it starts with HTML, ends with HTML, and has a bunch of HTML tags if you're familiar with those. But that would describe a web page. And so if you had a web browser on your IoT device, it would read that data and then draw the web page, represent it the way that it's supposed to be represented for you. But you can see here that this protocol, this HTTP protocol, is application specific. It's for web transfers. It's got some header lines, which may or may not be useful to you, but the data is actually what you want to send. Thank you.